Now equation of a plane in normal form or vector form. Now I have drawn a figure here. Now let's discuss it first of all. Now consider a plane whose perpendicular distance from a given point or from the origin. Okay, so let's write it from origin. From origin is D. Okay, now this I have made O and this is D, perpendicular distance for point N. Now vector ON is the normal from the origin to the plane, and this is a unit vector. Okay, n cap, and n cap is a unit vector along vector ON. Therefore vector ON is equal to D n cap. Is it clear? Now let P be any point. Now I have drawn here P. Now this point is P. This point is P. Now let P be any point on the plane such that vector NP is perpendicular to vector ON. Therefore vector NP dot vector ON is equal to 0. Equation 1. Now let vector R, this one, let vector R be the position vector of the point P. Therefore vector NP will be position vector of P minus position vector of N. So this will be vector R minus D vector N. And we can also use by the triangle law of the vector ON plus vector NP is equal to vector OP by the triangle law. Now therefore equation 1 reduces to vector R minus D vector N dot D vector N is equal to 0, or vector R minus D vector N dot vector N is equal to 0, vector R dot unit vector N minus D dot unit vector N is equal to 0, vector R dot unit vector N minus D is equal to 0, unit vector N dot vector N is 1. We have already done this. Hence required equation. Now equation of a plane in the normal form, hence required equation of plane in vector form is vector r with n cap is equal to d. So it is negative of d, so we can write it is equal to d. So this is the equation which we have to remember.